talking about quantum numbers. There are four quantum numbers. There's the N, L, ML, and MS. The Pauli exclusion principle says that no two electrons in an atom can have identical quantum numbers. And so the quantum numbers are all unique for all of the electrons in an atom. The first quantum number is N. N is the principal quantum number, and it's all about shells. The value starts at 1. So its values are 1, 2, 3, 4, and so on. It can never be negative. It can never be 0. Now, the larger the N value, the higher the energy level. And to find the maximum number of electrons within a shell, you would do 2n squared. So in this diagram right here, the red dot is the nucleus. The first circle, the first shell, is where n is equal to 1. The second shell is where n is equal to 2, and so on. And the one with the larger n value, n is equal to 4, in this diagram itself, is the higher energy level, because it has the highest n value, plus it's the one that's farthest away from the nucleus. Now the one with the lowest energy value, or energy level, is level 1, where n is equal to 1, because it's the closest to the nucleus. So the closer you are to the nucleus, the lower the energy level. Now, to find the maximum number of electrons within a shell, you would do 2n squared. And so for level 1, if you want to know the maximum number of electrons within the shell, you would plug in 1 for n. 1 squared is 1. 1 times 2 is 2. There's 2 maximum number of electrons within shell 1. And then you would do the same for the other shells. The next quantum number is the azimuthal quantum number, and it's all about subshells. And the value starts at 0, and then it increments to n minus 1. And so the value for L could be 0, 1, 2, 3, and so on. It can never be a negative number, but it can have 0. It could be 0. Now the L number can also tell you about chemical bonds and bond angle. And also, the L values are also assigned letters. So when L is 0, the letter sign is S. When L is 1, the letter sign is P. When L is 2, the letter sign is D. And when L is 3, the letter sign is 4. Now, to find the maximum number of electrons within a subshell, you would do 4L plus 2. So for example, if you were to zoom in where n is equal to 1, you would see that it's just one shell, one main shell. And so because there's no subshells, L is 0, and because L is 0, the letter sign is S. For level 2, you would see that there's a main shell, and then there's one subshell. And so L is 1 in this case, and because L is 1, the letter sign is P. The letter sign is also S. So you would have 0, 1. So let me explain that further. So when n is equal to 1 for level 1, L is 0. When n is equal to 2 for level 2, L is 0, 1. When n is equal to 3 for level 3, L is 0, 1, 2. And when n is equal to 4 for level 4, L is 0, 1, 2, 3. And there are 3 subshells for level 4, because you have the main shell and then you have 3 subshells. Now for ML, which is the magnetic quantum number, that's all about the orbitals within the subshells, and its values could be 0, -1, +1, -2. It's just all positive and negative integers, including 0. And each of them they have a certain shape. So for example, for level 2, right? For level 2, n is 2, so L is 0, 1. ML would be 0, and ML will also be -1 +1, because remember, ML is 0, and ML is negative L and plus L, whatever the value of L is. So back to level 2, when L is 0, the letter is S. And so you have the sphere shape, and because it's level 2, it's going to be 2, S. Also for level 2, L will also be 1, and when L is 1, the letter is P. And so you would have 2P. But P is different from S because P have 3 different orbitals, right? You have 2px, 2py, and 2pz. And the thing with that is for ml, remember to find the maximum number of electrons for n, you do this. To find the maximum number of electrons for L, you would do this. But for ml, the maximum number of electrons is always 2. And so for 2s, you would have 2 electrons. For 1s, you would have 2 electrons. For 2px, you would have 2 electrons. For 2py, you would have 2 electrons. And for 2pz, you will have 2 electrons each, maximum. Now the next quantum number is ms. Ms is just the spin quantum number, and it's all about motion and spinning, because the thing is, when electrons move around the nucleus, they have a momentum. And so when you have 2 electrons, for example, in the same orbital, what happens is that since they repel each other, they will spin in the opposite direction. And so they will be paired, right? They're spinning in the opposite direction, and so they have different ms values. One of them will be plus half, and the other one would be negative half. Now, electrons in different orbitals, let's say if there's an electron in 2s, and then there's another electron in 2p, and they're moving in the same, or spinning in the same direction, they will have a parallel spin, right? Because they're spinning in the same direction. And that's mostly because they are in different orbitals. They don't have to repel each other because they're not in the same orbital. And so they will spin in different directions. Now let's look at this table. So these are more examples. Let's do 1 and 2. For shell 1, when n is equal to 1, right? L will be, since L is n, because L is n minus 1, if n is 1, L will be 0, right? And if L is 0, right, n is 1, L is 0, and because L is 0, the letter sign when L is 0 is S, and so the notation would be 1s because it's the first level, and the notation is S, so it's 1s. To find the maximum number of electrons in a shell for n, you would do 2n squared, you would plug in 1 for n, so that would give you 2 electrons after you calculate it. Now to find the maximum numbers of electrons in subshells, in a subshell you would do 4l plus 2, and so you would plug in 0 for L, because remember L is 0, and so you would do 4 times 0, which is 0 plus 2, which is 2. So you have 2 maximum numbers of electrons in that subshell. Or in that shell, because there's no actual subshell here. Now for ML can be 0, and ML can be plus L and minus L. And so when L is 0, ML is 0. And the shape is a sphere because of the 1s notation. Now, for ml, the maximum number of electrons in each orbital is 2. It's always 2. Remember, for ml, it's always 2. Maximum number of electrons, there will be 2 in each orbital. And so it would be 2. And then for ms, which is all about spin and momentum, it would just be plus half and minus half. Now let's do shell 2. For shell 2, n is 2, L is 0, 1, L is 0, and L is 1. Now to find the maximum number of electrons in the shell, you would do 2n squared. So you would plug in 2 for n, and the reason you would plug in 2 is because this is the second shell. We're doing the second shell, and so n is 2. And then you would have 4, 2 squared is 4, 4 times 2 is 8, so that's 8 electrons. Now remember L is 0 and 1, and so the notation for when L is 0 is 2s, and the reason it's 2s because it's level 2, it's shell 2, and S because when L is 0, the letter sign is S. And then you would have also 2p. The reason you would have 2p is because when L is 1, remember L is also 1 in level 2. When L is 1, the letter sign is P. When L is 1, the letter sign is P. And so you would have 2p because it's level 2. But the thing with P is that you have the X, Y, and Z coordinate, so it's actually 3 orbitals. And 2s is just 1 orbital, but 2p is 3 orbitals. Now the maximum number of electrons in each in a subshell could be calculated using the 4L plus 2 equation. And so you would plug in 0 for L, you would get 2 after calculating it. And then again, you would plug in 1 for L, and then you would get 6. And the reason you get 6 electrons is because there's 2 electrons in the 2pxy coordinate orbital. There's 2 electrons in the 2py orbital, and then there's 2 electrons in the 2pz orbital. So altogether, it's 6 electrons for the 2p orbitals. Now for ML, right? ML could be 0, plus L, and negative L. And so when L is 0, ML is 0. And the shape is fair, 2S notation because the second level, and S because when L is 0, the letter sign is 0. The letter sign is S. So 2S, shape is fair. It's fair, right? For the 2p orbital, right? The notation, the L value is 1. Because the L value is 1, ML is plus 1 and minus 1. And so you would have 2px, 2py, 2pz. And the shape is a dumbbell shape. 2px, dumbbell shape, 2py, dumbbell shape, 2pz, dumbbell shape. And remember that the maximum number of electrons in each orbital is always 2. And so you would have 2 for the 2s orbital, right? Then you would have 2 for the 2px orbital, 2 for the 2py orbital, and 2 for the 2pz orbital. So for the 2p orbitals, you would have 6 in total because you would have 2 electrons each. So 2 times 3 is 6, so there's 6 electrons in the p orbital, and then you have only 2 electrons in the 2s orbital. Now for the ms, which is all about spinning and momentum, you would have plus half and minus half for the 2s orbital, and then plus half and minus half for the 2px orbital, plus half and minus half for the 2py orbital, and then plus half and minus half for the 2pz orbital. Now just to summarize, or just give you, just to explain a little bit, for example, if n is equal to 2, right? Let's start with n is equal to 1. When n is equal to 1, L is equal to 0. The letter sign is S. ML will be 0. And MS will be plus half minus half. When n is equal to 2, right? L will be 0, 1. ML will be 0, plus 1, minus 1. And MS will have plus half, minus half, plus half, minus half, and plus half, minus half. And then the letters assigned will be S and P. And since P has 3 orbitals, you have you would have 2px, 2py, 2pz. When n is equal to 3, L is 0, 1, 2. ML would be 0, plus 1, minus 1, plus 2, minus 2. The letters assigned will be S, P, D, because when L is 2, the letter sign is D. S, P, D. P has, like I said, 3 orbitals, and D has 5 orbitals. But the shape of D and F don't really matter for the Mcat. You just need to remember that there are a part of the notations assigned. So for when n is equal to 3, you have S, P, D, and then MS, you will have you would have plus half and minus half for each of the orbitals. And that's pretty much it. See you next time.